Hello everybody. Today's lesson is on section 10.4 on using coordinate proof with the distance formula with quadrilaterals, and that is section 10.4 in your book. So go ahead and open your books to page 539. And on page 539 we're going to start with problem number 5. We're going to use the distance formula to prove that the diagonals of figure ABCD bisect each other. So we're given points A, B, C, and D. We'll just start with a rough sketch. Point A is at 3, 2. Point B is at 8, 2. Point C is at 5, 0. And point D is at 0, 0. So there's our figure, and we're going to try to prove that the diagonals bisect each other. And actually we won't use the distance formula for this one to tell if the diagonals bisect each other. We just need to see if the diagonals intersect one another at each other's midpoint. And so the midpoint of diagonal AC, the midpoint of AC is the average of the x coordinates, 3 plus 5 divided by 2, and the average of the y coordinates, 2 plus 0 divided by 2. So that is 8 over 2 is 4, and 2 over 2 is 1. So the midpoint of AC is at 4, 1. And the midpoint of BD would be the average of the x coordinates for point B and D. So that's 8 plus 0 divided by 2. And the average of the y coordinates, 2 plus 0 divided by 2. That is 4, 1 also. And so since the diagonals have the same midpoint, that means they pass through each other's midpoint, so they're bisecting each other. And so we can say, since AC and BD have the same midpoint, AC and BD bisect each other. Okay, so that completes example number 5. And now we'll skip forward to problem 7, which is on page 541. So here in the directions it says, prove or disprove each statement about the quadrilateral, WXYZ. And we're trying to either prove that it's a rhombus or disprove that it's a rhombus. The work for that would be the same. The definition of a rhombus is a quadrilateral that has 4 sides congruent. So all 4 sides need to have the same length. And so we'll use the distance formula to find the lengths of the slanted sides. We can tell already that the length of XY is 1, 2, 3, 4, 5. And the length of WZ is also 5. So we know those are the same, but we need to use the distance formula to find the length of WX and YZ. And so to find the length of WX, we need the coordinates for each point. So W is at 0, 0, X is at 4, 3, Z is at 5, 0, and Y is at 9, 3. So the length of WX we would do the distance formula. That's the square root of the difference in the x-coordinates, 4 minus 0 squared, plus 3 minus 0 squared. That is 16 plus 9, or square root of 25. Okay, so now you go ahead and find the length of yz by doing the distance formula. Press pause on your video player, go ahead and find the length of yz, and then press play when you're ready to check your solution. So to find the length of yz, we need to take the difference in the x-coordinates. So I'm going to do 9 minus 5 squared, and then the difference in the y-coordinates, 3 minus 0 squared. And that's the square root of 4 squared plus 3 squared, which is also the square root of 16 plus 9, or the square root of 25. Both of these are actually equal to 5. So now we see that all four sides, we have xy is 5, we have wz is 5. We could get those easily because those were just horizontal segments. And then we use the distance formula to find that these are also 5. So since all sides of wxyz are congruent, since they have the same length, then wxyz is a rhombus. If we got that one of those lengths was different, then we'd be able to prove that it's not a rhombus. But in this case, since all four lengths are equal to 5, we know it's a rhombus. All right, now go on to the next page. And we're going to use the diagonals to determine whether this is parallelogram, is a rectangle, rhombus, or square. So they're already telling us in the directions. We know it's a parallelogram. And so you want to think about the properties of the diagonals for rectangle, rhombus, and square. Rectangles have diagonals that are congruent. So they have that means they have the same length. So you could use the distance formula to check the lengths and see if they're the same. A rhombus has diagonals that are perpendicular. So if I have a rhombus, the diagonals form right angles. And a square is both a rectangle and a rhombus. So if it turns out that the diagonals are congruent and they're perpendicular, that would tell us that it's a square. So I'd like you to go ahead and try this one. You can graph it here, or you can graph it on graph paper, and then check the properties of the diagonals to decide if it's a rectangle, a rhombus, or a square. So go ahead and pause your video, determine from your graph and the distance formula and from slopes what's true about the diagonals, and then you can, when you're all done, you can press play to see my solution. So I have plotted all 4 of the points, and now we're going to use the diagonals to determine what kind of figure this is. So first thing we want to do is find the length of the diagonals and see if they're congruent. And so we could find the length of LN by doing the distance formula. And so that would be 0 minus -2 squared plus -4 minus 4 squared. That is the square root of 4 plus 64, or square root 68. And then the length of KM, the other diagonal, let's see, we're going to have 3 minus -5 squared, and 1 minus negative 1 squared. That is 8 squared is 64, and 2 squared is 4. So we also get root 68. So that tells us the diagonals are congruent, which means it is a rectangle. Okay, now we're going to check and see if it's a rhombus as well by looking at the slopes. So the slope of ln, it is, let's see, if we start at point L, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, and over 2, down 8, over 2, that's negative 4. And then the slope of Km is, if we start at K, we'll go up 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So up 2 over 8, that is 1/4. And we can now tell that those are perpendicular slopes because they are opposite reciprocals of each other. Or remember, if we multiply the two slopes and get negative 1, which we do, that tells us that they are perpendicular. So Ln is perpendicular to Km, which tells us that it is a rhombus, because rhombuses have perpendicular diagonals. So it's a rectangle and it's a rhombus. If a figure is a rectangle and a rhombus, that means it is a square. So this figure, KLMN, must be a square. All right, and that completes the notes for section 10.1. Sorry, section 10.4. So if you need to, you can always go back and watch any of these sections again, and otherwise you're ready to go ahead and try the assignment.